Hello and welcome to the relearning for area, perimeter, and circumference of composite or irregular figures that are not on a graph. Please put the date that you've taken this and your name. You can use, um, there are papers in the back of 1029 in the blue box that match what I'm using on here, but if you're watching at home and you'd like to write it down on yourself, you can do that too and hand that in as you're relearning. Today we're going to cover two different standards, one for area, perimeter, circumference, and especially we're going to be looking at perimeter and circumference, and then the other one we're going to be looking at is specifically area. But right now we're going to start with our important formulas. The important formulas that you are going to need to memorize is the area of a triangle is 1/2 the base times the height. The parallelogram is base times height. This includes rectangles and squares as well as figures that are parallelograms that are on the slant. They have to have their sides parallel. The area of a circle is area equals pi r squared. Now again, I'm going to encourage you, you need to memorize these formulas in order to be successful at this standard. The circumference of a circle is C equals 2 pi r. C standing for circumference, and we'll be covering over what that actually is in a minute, but these are the basic formulas that you should be able to know for this standard. Okay, a short definition for area. It's the amount of squares inside, and this is the important part, inside a figure. So if we're going to look at an example, if we have a basic rectangle that we have in here, and a side is 2 centimeters tall and 4 centimeters wide. So what we're asking ourselves for area is how many squares are inside this figure. So let's break this apart. So there's 2 centimeters, 1 and 2 on here, and we're going to break this into 4 equal squares. So now when we're going to pretend that these are all equal. So how many do we have total? 1, 2, 3, 4, 5, 6, 7, 8. Or we can do 2 times 4. 2 times 4. And we're going to be looking at it that way. How many squares did we form? We can look at how long a side is and how wide a side is. And that's this, we want to know the amount of squares inside a figure. For perimeter, it's the distance around a figure. So if we look at that same example, we have 2 sides here, 4. Over here is also 2 and 4. What we're going to be doing for perimeter is we add those all up. Here you can see with area we're going to multiply, but here we're going to add them all up. And then specifically for circumference, is the distance around specifically a circle and only a circle. So we're looking at specifically, so circumference formula would only be used for a circle, as well as area would only be used for a circle. So let's look at some examples. Looking at the perimeter, we talked about this one a little bit up here, but let's do it more formally. If this is 4 centimeters, then the length of this line is 4 centimeters. If this is 2 centimeters, then the length of this line is 2 centimeters. So if I take my pen and I circle and I go outside here, we're not interested in the squares in the inside, which would be area, but we're interested in the outside. So we're going to take 4 plus 2, 4 plus 2 plus 4 plus 2, and we're going to get a total, that's a 2. We're going to get a total of 12 centimeters. We didn't multiply anything together. We added them all up, and therefore our units is in centimeters. For the perimeter in units here for a triangle, it's all exactly the same. We're looking at taking our pen or pencil and we're putting it around the outside of our figure. We're not interested in anything in the inside with perimeter. We're only interested in the outside. So the things that it touches, the length of this line, which is 13, plus the length of this line, which is 12, plus the length of this line, which is 5, and those all add up to 30. Our units are right here, millimeters. We didn't multiply anything, so therefore our millimeters stay as just millimeters. To find the perimeter of a parallelogram, this should be at a right angle. We're looking at this. This side and this side are exactly the same length. So the length over here is also 2 centimeters. But when we're looking at perimeter, we're only looking at the outside area. And again, take our pen and go all the way around the outside. So if this is 6, this is 6. If this is 2, this is 2. So we take 6 plus 2 plus 6 plus 2, and we get a total of 16 centimeters. 6 plus 2 is 8, 6 plus 2 is 8, and that's our 16. And we didn't do any multiplying, we just added them all up. When we have perimeter, we're just adding those all up. Now in circumference, we're again interested in only the outside. This part right here, we're interested in. And that's it. We're not interested in anything inside, just the part that touches that line. But because it's a curved surface, we have a special formula, and the circumference equals pi times 2 times r. Or we could also say 2 pi r, or we can also say pi times diameter. So in here, there's a couple things we need to know. This tells us the diameter is 6. So all the way around, is 12. All the way around is our thing. But if we're looking at our diameter, if we're looking from the center in, we divide that completely in half. That means this is 6 from the center to the edge, and this is 6 from the center to the edge. When we go from the center to the edge, we automatically know that that's the radius, because that's the definition of a radius. So if the diameter is 12, we divide it in half, and our radius for this problem is 6. So we're going to be using pi. Pi is only used for curved surfaces. Should never be in any formula for anything that has a straight line. Triangles, rectangles, parallelograms, all do not have pi. So we take our formula. C equals 2 times 3.14. In general, we use 3.14 for pi. It doesn't tell us that we have to have our answer in terms of pi, so we're going to use 3.14. We're going to multiply that by our radius of 6. When we multiply those all out, our answer becomes 37.68 centimeters. Again, we just take this right here, our outside edge, and when we have an outside edge, we're always talking about the length of the line, and that means we are in centimeters. As we get into more complicated figures, we're looking here at the perimeter of the following figure. Again, it doesn't matter that this is on an angle or we have a right angle symbols. That's nice to know, but that's added information. We're interested in knowing that we're taking the perimeter, and perimeter always means add. 13 plus 11 plus 16 plus 18. When we add those all up, we get 58 meters. Now we do multiply for the circumference, but that's the nature of our formula to get that edge, and that's only for a curved surface. Anything that has a straight line, we add those straight up. We might have to figure them out, but right now we just add them together as we're given. Now this is a more complicated figure. This is a composite figure, and we're going to look into this. We're going to take, again, we're interested in our perimeter. So let's just, because it's more complicated, we'll take our pen and we'll travel all the way around. Down, across, up, again over, and then we're going to be a curved surface and then back around. So when we travel, this has a number, has a number, has a number, has a number. This one does not, so we have to figure it out. So since how this is 6, this is also 6. But for this figure right here, this little curved surface, we have to use our formula for circumference. Circumference pairs up with perimeter. So C equals 2 pi r. But in here, we did that for C equals 2 pi r for a full circle. Here, we have a half a circle. So we're going to take our answer, and when we're done, we're going to divide it by 2. So what is the diameter here? What is the length of this line? Now we don't need it for calculating the circumference because our line does not cover that, but we do need it in order to get the curved surface that we have here. So if this is 5 and this is 2 and the whole thing is 10, this means this is 3. So the diameter is equal to 3. That means that the radius is 1.5. So C equals 2 times 3.14 times 1.5, and we're going to divide that whole thing by 2. And when we do that, our answer is going to become 9.42. So this curved surface, all of it is 9.42. That's the nature. We only multiply when we have circumference when we're thinking about perimeter. So when we add these up, we're going to add 10, starting here, going over here, plus 6, up here, plus 5, and then we're hopping around. And how much do we hop around here? We hop around 9.42, over here, plus 2, and then down, plus 6. When we add those all up, we get 32.42 units. We don't know what the units are, but we know that they're not squares, so we're just going to put units in here. Okay, so that's perimeter. On area, we're looking at these two figures here, these figures that are on here, and there's some specific things that we're going to look at. Now this is a rectangle, and if we're going to make our squares inside, because that's what we're looking at, is how many squares can we put inside here? How many? Sometimes we can count them, but usually we're going to take the base times the height. So we have 8. Each row has 8 across and 22 down. So how many does that make? That makes 8 times 22, which gives us a total of 176 centimeters squared. So we know that they're centimeters. They're supposed to be 1 centimeter apart. So we know that they're centimeters squared. Here comes our triangles, which seem to have gotten a lot of play in our lessons that we have, but it's a little tricky. When we're looking at these, we have to think about this. If you can see it in here, it's almost like this is a half of a square. A half of a square. So if a square is base times height, a triangle is half of that. Sometimes we write it as 1/2 the base times the height. These two things are exactly the same. We're going to take the base times the height and we're going to divide it in half. So how many squares can we make if we have 12 lines across up here and 3 this way? Well, the 13 is added information. It's stuff that we don't know. So this is equal to 1/2 of 12 plus 5, or excuse me, times 5, which gives us 1/2 of 60, which gives us 30. So what we're talking about here is if we had a square, we don't, we have a triangle. If we had a square, we would do base times height. But we have a half of a square, which means we have a half to be able to multiply it by our 60 to get 30 units. So if we were to look in here, some squares might be bigger or might be fuller than others, but if we were to add them all up, we would get 30 units. In our parallelogram, this caused a lot of problems for people on the test. So basically what we're looking at, we have our symbols here that tell us that these are both parallel. We have our directions that tell us a parallelogram. And we have our right angle symbol. So what is the height of this? This is 2. But it says it should connect here to the bottom. So we need to figure out, this is 6, so therefore this is 6. So this is base times height, which is 2 times 6, which is 12, and it says it should be centimeters squared. We multiplied them together, our centimeters squared. So how can this be? It's on a slant, and we know that a square is supposed to be easiest for us to see how many squares inside. If you take a look at this, if we were to put a triangle here and we were to flip it over and bring it right over here, you can see that that would create a rectangle. That could create a rectangle. But if you are having trouble seeing that, know that it's always base times height. Sometimes we can break those up into different sections and calculate them that way. But you got to be careful what you have in here to keep track of your information. Base times height, parallelogram. Number 14. This is a regular polygon, So what we're going to do here is this is perpendicular to the base. We know that when we have a regular polygon, everything is 12. This is 12, this is 12, this is 12, this is 12, and this is 12. All the sides are the same. In the middle here, we have a center, so when this drops down here, we can create triangles. So we have in here 3 and 12. So we know our formula for triangles, 1/2 the base times the height. We should have that memorized. The base is 12, that's at the bottom of our triangle, and the height is right here, which is 3. I'm going to rewrite this here. 1/2, 12 times 3. So when we do that, it's 1/2 of 36, getting ahead of myself, which is 18 inches. So inside here, this is 18 inches. Well, it just so happens that if we were to make triangles from that center all the way out, this would be 18, this would be 18, this would be 18, and this would be 18. Now remember, our perimeter says that we would be on the edge. So I'm not interested in the perimeter, I'm interested in the number of squares that are inside. That means that there would be 18 squares here, 18 squares here, 18 squares here, 18 squares here, and 18 squares here. So how many total do we have? When we've done the formula, in effect, 1, 2, 3, 4, 5 times, we can add up all the totals. But we know when we add multiple things, we can also multiply them. 1, 2, 3, 4, 5. 18 times 5 gives us a 90 inches squared. It just so happens that we have 5 sides, which is also makes 5 triangles. And this works for regular polygon. It's a special area of section of area. Okay, we have a couple more, and then we'll have you try. So we're looking at this. We're looking at area. So we have our lovely circle that we had on the other page, but we're not looking for circumference anymore. We're looking at how many squares can we put in here if our diameter is 12. Well, it so happens that people have figured that out as it's equal to pi times the radius squared. So if the diameter is 12, again, when we go from the center to the side, that's our radius, which is 6. We take 3.14 times 6, which is 6 squared. Multiply those together, and we get an answer of 113.04 centimeters squared. So if we were to take a circle and do it 12 centimeters across, circle it all the way around, and how many circles or how many squares we would find in there, we would find that we would have over 100 squares inside our circle. These squares inside here, and they would be all 1 centimeter apart, 1 centimeter wide. It's kind of a lot of squares that we would have in there. It's lovely that we found that this pi is 3.14. When we're looking at the area of a composite figure where we've got a bunch of different things in here, we're just going to break it down into our shapes that we like. We're going to break it down into the shapes that we like. Now, I see in here 4 shapes. So I'm going to do figure 1, figure 2, figure 3, and figure 4. So it's kind of, we're going to look at each shape, and we're just going to break it down. So right now we're just going to look at this semicircle that we have here, this half a circle. So we're talking about area. So area equals pi r squared, but we don't have a full circle here. We have a half a circle. So we have to divide it by 2. So this equal to 3.14 times 4 squared. If this is 8, the whole way across from the center back is also 4. So when we're looking at it here, we do 4 times 3.14. That gives us a 50.24. And we're going to divide that in half. And that gives us an answer of 25.12 units squared. What that means is inside this half a circle, we would have about 25 and a little bit more units squares inside this half a circle. So let's look at the center one. This is figure 1. Figure 2 is this one right here. Well, this whole length all the way across is 13. But if we look at it here, this side, we bring it down, this is 8, this whole thing is 8, and then this whole thing is 8. So we don't want the whole line because we have 2 triangles on either side. So we're taking our base is 8. So we're just making squares right here. That's 6 times 8, which gives us 48.